Hello students, welcome to Prime Educare, Complete Institute for JEE and NEET. My name is Sharul and I am your physics faculty. So students, what we were studying about? We were studying about the various types of quantities, like we have the base and the derived quantity, we have the scalar and the vector quantity. So this we are having the discussion. Now we were talking about the various type of units of physical quantities, like how do we measure it? How do we measure it? Like we have seen the various type of base quantities. So what all types of base quantities we have seen? We have seen like mass, length and time. So we have seen the various types of base quantities. So but to measure it, like if we have to measure the length, like if we have to measure this is L1, this is L2. Like if we have to differentiate whose length is greater, whose length is smaller, which is smaller, which is greater, L1 is greater or L2 is greater, if we have to find out whose length is greater or smaller, then what do we have to do? We have to measure it. We have to measure it, and then also we have the various types of length we come across. Like if we have to measure the length of a, let's consider the length of a table, and if we have to consider the distance between earth and the moon, so we know we can imagine that there is a difference in length, and there is a huge difference in length. Like if we have to talk about the distance between earth and moon, then it's very larger. It cannot be measured in just centimeter or a very small unit. But if we have to measure the table length, that can be measured even by us also, even by a normal human being. But to measure the distance between the earth and the moon, we have to use a certain other type of other type of instruments to measure that distance. Now students, like if we have, so when these units were discovered to measure the length, like if we have kilometer, we have meter, we have various type of units to measure the length. So what was the first initial discovery for this units? So we have the British engineering system. So we have first the British engineering system, which was discovered in British, obviously. So this system was FPS. What was this system? Was FPS. So we know that there are three fundamental units. We have mass, we have length, we have time. So these are all the three fundamental units: mass, length and time. Now if we talk about FPS, then F is foot, so foot is length, and mass is pound, and time is second. This is the duration. Time is the duration to perform a task. So this is first described as the FPS system, where in the FPS system we have the foot, pound and second. That is the British system. Then for the second system we have the CGS system. We have the CGS system, we have the Gaussian system. In the CGS system we have the centimeter, gram and second. So we have these three types of units. We have the centimeter, we have the gram and we have the second. So this is the Gaussian system, where to measure the length we have centimeter, mass, gram and time is second. Now we have the MKS system. Now students, we are having the MKS system. So MKS system is also a standard system, where to measure the length we have meter. If we have to measure the mass, we have kg, and time is for second. So there were various types of discoveries which were happening across the world. So to give a standard notation, like if there is a discovery that is going in India, and to label it same as going in other part of the world, the scientists have given the SI system, international system, where there is a standard units for various types of quantities. So that basically comes with the three fundamental system, where we have the three MKS unit, that is meter, kg and second. So this is the three basic units. Now In addition, apart from this, scientists have also given the other four fundamental quantities and two other quantities to measure the various types of quantities. So this is all about the measurements of the unit. Now, students, to measure the length, we have meter, mass, kg, time, second. For the so what were the other four quantities that were also included in it? So we have the length, mass and time that were initially discovered, but then there was an inclusion of other four quantities. So what was these four other quantities that was also introduced? We have the temperature, we have the electric current, we have the luminous intensity and amount of substance. So what is the temperature? It is the degree of hotness or a coolness, like ice freezes at 0 degrees Celsius. So here we talk about the temperature. It's not that at 100 degrees Celsius the ice will not be in the form of ice state. So the temperature is measured in Kelvin. So this temperature is measured in Kelvin. So we have the standard unit for temperature, like for the mass we have the kg, for length meter, time we have the second. Then to measure the temperature we have the Kelvin. Then to measure the temperature we have what is we have the unit of Kelvin. Now students, if we say about the electric current, if we say about the electric current, then in the electric current, yes, so if we say about the electric current, we have the electric current is the total charge flown per total time taken. So electric current is the total charge flown per total time taken. So that is the total amount of charge flown per time taken, that is the electric current. To measure the electric current, we have the unit ampere. So what does the electric current measures? It measures the total charge flown per total time taken. Then was the inclusion of luminous intensity, which measures the amount of light that is generated per unit area. The amount of light, the intensity of light. And how to measure that intensity of light? We measure it in terms of candela. So in the unit of the candela, we measure this luminous intensity. Then comes the amount of substance. Then amount of substance means if we talk about the atoms and nuclei, here the mass is very much small. Here we have the very less number of less number of atoms. So we have very less number of atoms in it. Then to measure this amount of substance, we have the unit mole. So this we will study later on, what is mole. So these are other four fundamental quantities which were also included other than length, mass and time. Now students, let's go further. So in the classification of units, we have first we have the derived units, we have the base units, fundamental units and supplementary units, practical units and improper units. So we will talk about each type of units. So first of all, there are 7 base type of units. So we will talk about first the base units, which are the fundamental units, which are not dependent on anything. Like we have the mass, length and time. So the mass is not dependent on any other quantity. So if we talk about the mass, it is not dependent on any other quantity. If we talk about length, it is not dependent on any other quantity. If we talk about your time, it is not dependent on any other quantity. So these were the base units. Then come the derived units, which are based on base units. So derived units are based on base units, like if we have derived units such as force. So if we talk about the force, force is dependent on mass, also on acceleration. So this force is dependent on mass as well as the acceleration. So it is dependent on base quantities. So if we say about the derived quantity, these derived quantities, students, are dependent on the base quantities. That is the fundamental quantities. Base quantities are independent. Derived units are dependent on the base units. Now, so force, frequency, then come the supplementary units where we will include it, like the steradian, radian. So these are used to measure the angles. So what is radian? If we talk about the radian, then radian is like if we have a circle, if we have a circle, then what is this arc angle subtending on it? So we measure this angle theta. Theta is to measure this angle. Theta is the angle. So angle is measured in, we already know angle is measured in degree. So we measure the angle in degree. But in physics we have the other unit, that is radian. So in physics we measure it using radian. So angle is measured in degree, but in physics we have the unit called radian. So radian measures that what is the angle subtended at the arc of this circle. So what is the angle subtended at the arc of this circle? What is the steradian? Steradian is a 3D. If we talk about radian, it is in 2D. Steradian is in 3D. So steradian is in 3D and this radian is in 2D. So steradian is the angle subtended by a sphere. So it is the angle subtended by the sphere. So sphere, what is the area of the sphere subtended the angle? That is the steradian. Then comes the students' practical units. So what are the practical units? Practical units are those which are user friendly and which we talk in general. Like to measure the power, we have the horsepower. So usually the what unit we use in the general practice is the horsepower to measure the power. So we have the general practice of using the term horsepower in general practice to measure the power. So horsepower is generally used to measure the power. Then comes the improper units. So improper units are those units which seem like the unit of other quantity. Like for example, we have the kg weight. So if we have the kg weight, so kg is actually used to denote the mass. Kg is usually used to denote the mass, but here we are, what do we are measuring here? We are measuring here the force. So here kg seems to be like the unit of mass, but here it seems like the unit of what does it seems like the unit? It is actually the unit of force. But what does it seems like? It actually seems like the unit of mass. So these are all the various types of units we have. So we have the derived unit, we have the supplementary unit, we have the practical unit, we have the improper unit. So if we talk about the fundamental unit, these are independent, derived unit are dependent. Supplementary units are the additional units which we have, like the radian and steradian. Then we have the practical units which we use in our daily life. Improper units, what are the improper units? Which are not, which seems to be the units of other quantity, not of the particular quantity. So now students, let's get to further. So we have talked about three fundamental quantities: length, mass and time. So in what is the unit of measurement in various type of system? Like we have various types of system. So what we have the unit of measurement in it? So in the CGS we have centimeter, mass, gram, and time we have the second. So these are the system in other various quantities: centimeter, gram and second. MK system, we have meter, kg and second, and in the FPS, feet, pound and second. So these are the various types of units to measure in various types of classification of the units. Now you students, now let's talk about the force. So force we have in the CGS system. CGS system was originated in France. MKS also originated in France, but FPS was originated in Britain. So in the force we have in the CGS, which is Dian, but we have to consider the standard unit. In the to measure the force, we have to consider the standard unit, that is Newton. So we are considering standard unit Newton. For work and energy, we have joule, and for power, we have watt. So to measure the power, we have watt, and energy we have to measure it is joule, and force in Newton. But in the CGS, we have the Dian, erg and erg per second. Now what is the FPS? In FPS we have poundal. So what is a poundal? Poundal is the force done To move a 1 pound of substance move a 1 pound of substance by 1 feet per second square. So to move, what is 1 poundal? 1 poundal is to move a substance of 1 pound by 1 feet per second. So this is poundal where we are moving a 1 pound of substance by 1 feet per second. For work and energy we have feet poundal, and similarly for the power we have the feet poundal. So power and energy. So this is all about the various types of units to measure in various types of systems. Now students, let's get further. Conversion factor. What do we understand by the conversion factor? Like if we are measuring the mass in kg, like if we are measuring the mass in kg and if we have to measure the mass in gram, then how to change it? How to change it from kg to other form? So that is called the conversion factor. Like if we have to change the mass of kg to gram, how to change it? To measure it, how to change the kg into gram, we have to multiply it with 1000. So we multiply that with the unit to measurement. So we multiply that with the unit to measurement to measure it in the other quantity. So that is called, the students, what do we call as the conversion factor, how to convert the one unit into another. So now if we look into the example, so if we have the acceleration due to gravity, so what is the acceleration due to gravity is given? It is given 9.8 feet per second square. So we have the acceleration due to gravity, it is given as 9.8 meter per second square. So this is the acceleration due to gravity is given, which is 9.8 meter per second square. So we have the acceleration due to gravity which is given as 9.8 meter per second square, and if we have to change it in the feet per second square, so how to change it? So what is 1 meter equal to? 3.28 feet. So this is what is 1 meter is 3.28 feet. Now if we have to change it, so what it is all given? It is all given 9.8 meter per second square. So to change it into feet per second square, what do we have to do? 9.8 into 3.28. So when we multiply it, it comes to 332. When we solve it, the value comes out to be 32 feet per second square. So this is the unit which comes across. Like if we have the acceleration due to gravity, so if we have the acceleration due to gravity which is given as 9.8 meter per second square, if we have to change it into feet per second square, then we have to multiply it by the conversion factor, by that quantity which is 3.28 feet, and then on multiplying we get the answer. That comes out to be 32 feet per second square. That is the answer in feet per second square. Okay students, so I hope you have got the concept till now. So this is all, let me recall it what we have studied till now. So we have gone through the concept of units. So what is the concept of unit? To measure the various quantities. So we had the three base quantities, and then we looked into other supplementary units and the derived units. So what are the derived units? We have the force, we have the work, we have the power, and then we look into the various types of systems which scientists have discovered to measure the units in under various system. Like we have the FPS system, we also had the CGS system, then we had the SI system, that is MKS system, which is the standard system followed worldwide. So students, this is all about the units. So this is all about the units, like how to measure the various quantities under how to measure the various quantities, and what is the measurement of how to measure them. And now we will talk about the dimension. So in this chapter, we have the one concept of units. Now the concept of dimension. So student, let's understand the concept of dimension. What is a dimension? So this concept was actually discovered around 300 BC, where Aristotle gave the various fundamental dimension for, like, what line, we have the plane. So for the line we have the one dimension, we only need this one dimension, that is length. And for the plane we need two dimension, that is length and breadth. So firstly, so this was the basic discovery of the dimensions. Then in 1863 Maxwell gave the concept of the dimension analysis in physics, like for the mass, length and time. So mass, length and time, so then there comes the discovery for the dimension in the physics quantities. So firstly it was only in maths, but in around 1863 Maxwell gave the dimension concept in physics. So we have, what do we have? We have the mass, we have studied about, these are the base quantities, mass, length and time. So these are the base quantities. Now students, so what is dimension? Dimension is the power to which these base quantities are raised. So like, if we talk about the force, if we talk about the quantity force, then how is this force quantity is dependent on mass? How is this quantity depend? How it is m to the power 1 or mass to the power square. So how do this force is dependent on this mass? It is m to the power 1 or it is m to the power square? Or how is it dependent on length? How is it dependent on time? So there are certain limitation of also of this which we will come through, but the concept of dimension is very easy. Just to know that how each quantity are dependent on the base quantity. So we know that the derived quantity are dependent on the base quantities. Like we have the concept of force, it is dependent on mass, mass, length and time. But how these quantities are dependent? It is a square, it is a cube, it is the fourth time power. So we all understand using the concept of dimension in it. So we will understand with the concept of dimension in it, like how these quantities are dependent on each term. So dimension formula of any physical quantity is that expression which expresses how and which of the following base quantities are included. How it is written? It is written using the square bracket. So now if we have the dimension formula for mass, so mass, how we will write it as m l t. So m to the power 1, it is not dependent on length, so it is power 0, and t, it is not dependent on time, so it is also to the power 0. So m to the power 1, l to the power 0, t to the power 0. So students, now we have, these are the various quantities in the physics which will come across in the entire 11th and the 12th. So these are all the quantities which we come across in entire 11th and 12th. So if we have to find the dimension, so we have first the length. So what is the dimension of length? It is m to the power 0. Length, it is not dependent on mass, so it is power 0, length 1, t to the power 0. Area, area is dependent on, what is area? If we know the formula, area is side square. So area is side square, so area is dependent on the length. So area is actually dependent on the length. So area is actually dependent on the length, so it is L square, t to the power 0 and then again m to the power 0. If we talk about the volume, so volume is also side cube. Volume is side cube. So how it is dependent on the length? It is dependent on the length to the power L cube. So in the side we have the m square and in the L cube and t to the power 0. So this is how we can find the various dimensions of each of these terms. So let's consider the force. So what is force, students? Force is, so what do we understand by the force? Force is mass into acceleration. So what is force? Force is the push or pull of an object. So what is force? It is mass into acceleration. So mass, it is m. Acceleration, so what is mass? It is expressed as m to the power 1. Acceleration, meter per second square. So force is mass into acceleration. So mass is m to the power 1. Acceleration is meter per second square. So we denote it as L to the power 1 t to the power minus 2, because it will go in the numerator ms to the power minus 2. So meter in length and time s to the power minus 2, which will equal to t to the power minus 2. Now students, we have similarly we have, let's consider, we also have come across the term electric resistance. So what is resistance? Resistance is, so we can find it out, resistance is voltage upon current. So according to Ohm's law, resistance is voltage upon current. So what is voltage? Okay, we have to first know, for the voltage we should know the dimension for work. So what is work? So what is work? Work is force into displacement. So work done is equal to force into displacement. So what is force? It is m L t to the power minus 2, displacement is L to the power 1. So force is m L to the power 1 t to the power minus 2, displacement is L to the power 1. So it is equal to m L square t to the power minus 2. So this is the unit of work done. So what is voltage? Work done upon length. So m L to the power t to the power minus 2. Then for current we have the standard notation, which is I. So current we express it using I. So this is how we express the dimension for electric resistance. So it will be in the numerator, it can be go, which is m L current to the power minus 1 t to the power minus 2. So this is the dimension for electric resistance. So this is how we can find the various dimensions by knowing the concept, by knowing what is the formula and what is the concept of it. Okay students, so for the mass we label it using m, for the length we use L, and for the time we have t. So now let's come into this concept. So the equation obtained by equating the physical quantity with its dimensional formula is called dimensional equation. So what do we call it as? Like if we have this m to the power 0, L to the power 1, t to the power minus 1. So this is the dimension. This is the dimensional equation. What do we call it as? The dimensional equation. So this is called the dimensional equation. For example, this is a dimensional equation for each of the units. So application is where, like, how to find the various dimensions. So this is the numerical value, how it is denoted as, like how it is dependent on mass, how it is dependent on length and time. Now if we have to change this physical quantity from one system to another, then what do? We have to multiply with the factor of the unit factor. Like if we have the length in meter, then to know it in the centimeter, so we have to change it into 100 centimeter. So what is 1 meter? 1 meter is 100 centimeter, so we have to multiply it. So this we have already gone through the concept of conversion. Now students, like if we have to change this 1 Newton, so this, let's consider this 1 Newton. So 1 Newton is the unit of force. So 1 Newton is the unit of force, and this is the SI unit. So 1 unit is the SI unit, and this is the unit of force. So how to change to 1 Newton into 1 Dian? So 1 Dian is CGS unit. So 1 Dian is CGS unit, 1 Newton is the SI unit. So 1 Newton is SI unit and 1 Dian is the CGS. Now if we have to change the 1 Newton, so students, what is 1 Newton is actually is? So if we talk about what 1 Newton is actually is, so 1 Newton is 1 kg. So what is 1 Newton? So 1 Newton is actually 1 kg meter per second square. So 1 Newton, so what is, student, what is this 1 Newton is? 1 Newton is 1 kg meter per second square. Now if we have to change this kg into the CGS unit, we have the SI unit. SI unit is Dian. SI unit is Newton. So we have the SI unit which is Newton, but now if we have to change it into the CGS unit, into the next unit. So we have 1 Newton, 1 kg meter per second square. Now if we have to change it 1 kg into CGS. So 1 kg into CGS, it can be written as gram. So 1 kg can be written as 10 to the power 3. And then in meter. So what is meter? What is 1 meter? So 1 meter is 100 centimeter. So 1 meter is 100 centimeter. So it can be written as 100 upon. So this is kg. So what do we write it as? In gram. Then for meter, we write it as an centimeter. So for meter, we write it as in centimeter and then per second square. So this comes out to be equal to, what does this value comes out to be? This is centimeter per second square. So we have 1 kg, if we have to change it into the CGS unit. So 1 kg can be written as into 10 to the power 3 gram. Then 1 meter can be written as 100 centimeter. So what do we can write it as? 10 to the power 5. This is equal to gram. This is centimeter per second square. So this comes out to be the unit for force in Dian. So this comes out to be the unit of force in Dian, where for 1 kg it is 1000 gram, 1 meter equal to 100 centimeter. So this unit is 10 to the power 5 gram per centimeter square. Okay students, now let's get further. So application of dimensional analysis. Where do we use this dimension? So that was the unit conversion in the previous numerical, but where do we use this dimension analysis? To identify which all physical quantities are same. Like if we have the quantity work. So what is work? Work is force into displacement. So what is work? Work is force into displacement. So we have, for the work done, we have force into displacement. So what is the unit of the force? What is the dimension of force? It is m l t to the power minus 2. So this is the dimension of force, which is m l t to the power minus 2. Then comes the displacement. So how it is dependent on displacement? So what is displacement? It is length. So displacement is length. So this is length. So what do we will write it as? M L square t to the power minus 2. So here we can see that the dimension of work is ml square t to the power minus 2. Then comes the energy. What is energy? Half mv square. Half mv square, which is equal to, here also what we can write the dimension, kg can be written as m, and velocity we have L square t to the power minus 2. So here we can see that both the work done and energy have the same dimension. And with the help of the dimension, we can also identify how each term is dependent on the factor, on the length factor, on the time factor. So how is it dependent on the mass? How is it dependent on the length? It is square. And how is it dependent on the time? It is inversely proportional. So inversely proportional to time square. So if we study in detail, then work is actually how it is, work is coming out to be. Work is coming out to be directly proportional. Work is coming out to be directly proportional to mass. Work is coming out to be directly proportional to L square and then inversely proportional to T square. So this is how the work done is dependent. So work done is dependent on mass to the power 1 L to the power square and T to inversely proportional to T square. So it is inversely proportional to T square. So this is the application of the dimension. Now students, if we now let's we have gone through the dimension, we've gone through how each term is dependent. Now we will understand the accuracy of each term. Like if we have the time period, which is 2 pi root L by G. So we have the time period of a simple pendulum, which is 2 pi root L by G. Now if we have to check the dimension, so time period equal to 2 pi root L by G. Now if we have to find the dimension, now for the time we have the dimension T to the power 1. 2 pi root L by G, let's see what is the dimension for it. For length we have the dimension L to the power 1. So for length we have the dimension L to the power 1. Now for G, what is G students? It is acceleration due to gravity. So G is acceleration due to gravity. So its unit is meter per second square. So the unit of G is meter per second square. So now if we have to identify G, this is meter per second square, this is length, this is time T to the power minus 2. So G, unit of G is length T to the power minus 2. So we can write it here, L T to the power minus 2. So this all gets cancelled. So T to the power minus 2 will go in the numerator and this will be equal to T to the power square. T to the power square, which comes out to be equal to T. So here if we look into it, here in the LHS, we have already have the time. In the LHS we already have the time T, and what it all coming in the RHS, it is also coming out to be equal to T. So in the RHS it is also coming out to be T. So this is T equal to 2 pi root L by G. So for length L we have written L, and for G L to the power T minus 2. So L gets cancelled, so it comes out to be T. Okay students, so this is how we have checked the accuracy of the dimension, like how on the LHS and the RHS they are both same. Now in application we have already gone through, like we can find using this principle of homogeneity, we can identify the dimension. Now let's get into this numerical. So let's first understand what it is saying. It is known that it is known that the time revolution of a satellite around it depends on the universal gravitational constant mass and the radius. We have to find the dimension of T, we have to find the dimension of T. So if we look into it, so how the T is dependent, time revolution is dependent on G, then it is dependent on the mass, and then how is it dependent on the radius. So time to complete a certain revolution, time period to complete a certain revolution, how is it dependent on G, mass and radius. So let's see, consider it is dependent upon on G to the power A. So now we will solve this numerical. Let's suppose it's dependent on G to the power A, on mass it is dependent on MB, and R it is dependent on C. So what we will write it as? We can write it as G. What is G is? Universal gravitational constant. So this is force. We know that force is equal to G m1 m2 by r square. So force is equal to G m1 m2 by r square. So what is G? It is force r square by m1 m2. So what is G? It is force r square by m1 m2. So we can write it as Newton meter square per kg square. Newton meter square per kg square. So what we can write it as? This is Newton, this is kg meter per second square upon kg square. So we can know that it is coming out to be kg to the power minus 1, kg to the power minus 1, then it is we have to multiply it also further. This is kg meter per second square, meter square, it is meter to the power cube, and then we have second to the square. Okay, so we have the kg per kg square, so it is kg to the power minus 1. Then we have the meter cube, meter square, meter cube per second square. So now we can write it down. So we can write it as force is equal to this G. So this G can be written as G can be written as kg to the power minus 1 meter cube and second square. So now let's suppose it is to G to the power A and T to the power B time period. So we have to talk about like how this time period is dependent on G, then how it is dependent on mass mb, and then comes how it is dependent on radius, which is to the power c. So it is G, this is kg minus 1 meter cube s to the power minus 2 a. Now it is m to the power b, and then for the radius of the earth we have the length to the power c. So now if we say this is m to the power minus 1 L to the power 3 time to the power minus 2 to the power a. This is m to the power b, this is L to the power c equal to t. So now if we label it, so we have the minus 1 a plus b is equal to 0, because on the right hand side there is no factor of mass. In the left hand side we have the factor of mass, but there is no factor of mass on the right hand side. On the left hand side we have mass minus a plus b equal to 0. Then here we have L to the power 3. So this is 3a plus c equal to 0 because there is no factor of L. Then comes minus 2a, but here there is nothing included in b and c, there is only minus 2a, and in the right hand side we have t to the power 1. So it will equal to 1. So value of a comes out to be equal to minus half. So this is the value of a. We can put the value of a here. So if we put the value of a here in this, so if we put the value of a here, this is minus half. So we will find out the value of b, which is a, which is equal to b is equal to a, which is also equal to minus half. And then we can put the value of c here. So 3a plus c is equal to 0. So if we put the value of c here, we also will find the value of a. So we will find out like how this time is dependent on m, l and r. Now students, if we talk about the limitation, of this dimensional analysis, so what are the limitation is that if we have found for any physical quantity, like how the work is dependent. If work is equal to force into displacement, work is equal to force into displacement. So we know that it is dependent on m to the power 1, L to the power square, t to the power minus 2. But we don't know like what times, at what product value it is dependent on. We can't say that it is dependent on twice of L. We can only talk in the terms of linearly quartile or cube in the square, linear or cubical form. But we cannot justify it like how it is in the product wise, like is it dependent on twice, is it dependent on thrice or 4 times. Also there is, it also now gives information when it is in the trigonometric logarithm form. When we have the function in trigonometric form 10 something value or the log form, we don't know its dimension. So it's difficult to calculate this dimension. So this is all the application of dimension. Okay students, so now we will talk about the accuracy and precision. So what is accuracy and precision? So if we talk about the accuracy, so like if we are measuring, if we are doing a certain experiment. So if we are doing a certain experiment and let's say we are measuring the mass of a substance. So if we have the mass of this substance and if we are measuring it using a tool. So like if we have measured it, it comes out to be value m1, m2, m3, m4. So there were many experiments done and we have find out various types of mass in it, that is m1, m2, m3, m4, m5. So we have found out various types of mass of these objects by doing the experiments. So now what is accuracy and what is precision? So before accuracy and precision, we will understand the true value. So what is true value? So what is true value is m1 plus m2. So we will find all the averages m1, m2, m3, m4 plus m5 upon 5. So this is what is students call the true value if we found the average of all these masses. Now let's consider this. At the center we have the true value. We have the true value. If m1 values lies here, m2 values lies here, m3 value lies here, m4 values lies here. So we can know that this m3 value is very much close to this true value. M3 value is very much close to the true value. So this is what is called, we are calling as the accuracy. So we have done various experiments and with the experiments we have various types of measurements. So if the measurement is closer to the true value, if the measurement is closer to the true value, then what do we call it as the accuracy? Like how it is close. But if we have, and what is precision? Precision is when we have done the various experiments and the values comes out to be closer. Like let's consider the case here. If we have the true, this is at the center, we have the true value. At the center we have the true value, and in, let's say if we have taken the various experimental units, then if let's say this is m1, this is m2, this is m3, this is m4. So all these values comes at here, comes near here, like if this is m1, this is m2, this is m3, this is m4. So all the values are coming nearer. Then what do we call as the precision? So this is accuracy and precision. So accuracy refers to how close a experiment is to the true or accepted value. Precision refers to how close experiments of the same value are to each other. So these values are coming nearer to each other, m1, m2, m3, m4 are coming nearer to each other. So we call it as a precision. And in the accuracy, how near it to it, how near it to the true value. So for example, there can be a case when there is low accuracy, high precision, as well as vice versa. There can be a case when there will be high accuracy and low precision. For example, let's consider here at the center we have the true value. This is the accuracy. So here at the center we have the true value. And now let's consider if we have done the experiments. If we have done the experiments and if we have done the experiments, so let's consider M1 is coming here, M2 is coming here, M3 is coming here and M4 is coming here. So we know that M1 is more close to the true value. So M1 is more accurate. Now let's consider the another case when we have at the center we have the true value. This is the true value. So this is M1. Similarly, this is M2. This is M3. This is M4. So let me draw first all the types of cases so you can easily understand and differentiate them. So students, here we can see that all the experimental values M1, M2, M3, M4 are nearer. So here we say that they are more precise. Here the experimental values are more precise. Here what it is there, here M1, M2, M3 value are spread. They are not nearer, they are spread. So we call it as low precision. So here in this case, what do we call it as? This is a case of high precision because all the experimental values are nearer. But in this case, all the experimental values are far away. So we call it as low precision. So what do we call it as? Low precision. So this is called as low precision. Okay students.